Hello class. Today we're going to talk about trend lines. Now, this is the third part of our scatter plot series, where the first part we looked at what a scatter plot was. The second part we looked at how do I graph a scatter plot. Now the third one is what do I do with that scatter plot once I have it? Okay, how can I make predictions using it? Okay, so first thing we want to look at, what is a trend line? A trend line is just a line that's drawn through the data that kind of shows me the average amount of where each point is away from that. So in essence, back when we did mean absolute deviation, this is an example of mean absolute deviation. Because to find this trend line, I'm trying to find the average distance each one of those dots is away from the mean, is basically what it amounts to. So it says at the top here, it says a trend line is a line on a scatter plot drawn near the points that approximates the association between the data sets. So this trend line allows us to make predictions. So it says the trend line should be as close as possible to each data point, and there should be about as many points above the line as there are below the line. So based on this, we now, with this trend line in place, we can answer this question. Estimate the cost for 8 people. Okay, so this is number of people, this is cost in dollars. So I could come out here and look at 8 people, kind of draw a line up and hit that trend line. So based on that, I could say that 8 people would cost about $50. Okay? And that's how you read a scatter plot. Okay, so let's keep going with this trend line idea. So in this next slide, could you pick the best trend line for this particular data? It says, which of the lines shown are reasonable trend lines for the scatter plot? So we look at this data. Now this data is generally going downhill. So could this line right here be a good one? No, it couldn't, because it hits these 2 points and it doesn't track the general trend of the data. So no, that one couldn't do it. So what about this one right here? Well, this one does hit more of the data points, but we got a lot of points over here that aren't accounted for. Okay, so the one that would probably be the best line would be the one that's going right here. Okay, so that one would be the best trend line. It kind of approximates the majority of that data. Okay, let's see if we can do another one. Okay, what about this one? Which one of these lines should be best for this particular data? So again, line A right here, it's going the wrong way. Where most of the data is going uphill, this one's going downhill. So that's not really saying much. But what about B right here? Well, B looks like it hits pretty good. Okay, but we've only got 2 dots below the line and we got a bunch of dots over here. So what about C? Do you think that one would work? Well, between B and C, probably B would be the best one because it's hitting quite a few of these dots, where these 2 dots or these 3 dots right here, they're kind of outliers. They're kind of outside the scope of most of the data. Now, to be real honest, I think these 3 points right here would really pull our line to be more like that than it would anything because of where those are at. Okay, but again, the line we use it to show where the majority of the data is at so that we then can make predictions about it later on. So how do I create that trend line? What do I do to actually build that? Well, here is some data, and it says number of people, cost in dollars. So it's that same one that we looked at the very beginning. So what we have to do in order to create a trend line is the first thing we must do is we must select 2 points that represent the majority of the data. So we pick a point down here in the bottom of the data and a point up here in the top of the data, where if I were to connect those 2 points, it looks like it goes through the majority of the data, where there's about the same number of points on top as there are on bottom. So we've got this point and this point. So those points are 220 and 640. So that's the first thing that we do. Well, the second thing that we do is we find the slope. And if you remember, to find the slope, what you have to do is use that little formula, y1 or y2 minus y1 divided by x2 minus x1, and that's how we find slope. So if you'll look right here, they took the 2 points. So I have this 40 as my y2 and my 20 as my y1, and then I took my 6 as my x2 and my 2 as my x1. I subtracted each of those. I get 20 over 4. I divide that and I get 5. So that tells me my slope, my m, is equal to 5. Now I can use the formula y is equal to mx plus b in order to find my y-intercept value. So I take my slope that we just found, I plug it into my m right there, and I pick one of my points. So in this particular example, they used the 2 and the 20, and we pick that point, we plug the x value into the x spot, we plug the y value into the y spot, and then I evaluated for b. 5 times 2 is 10, so then I subtract 10 from both sides, I get b is equal to 10. Okay, so that allows me to find my y-intercept is 10. And now what we can do with that is I can then write the equation of my line, which is 5x plus 10. So I plug my slope into the slope spot, my y-intercept into the y-intercept spot, and we end up with that equation. Now what that allows me to do is then make some predictions. So it says use the equation of the trend line to make a prediction. So what do you think the cost of 10 people would be? Well, using that trend line going through here, I could actually come up here and say that 10 is going to cost about 60 bucks. But what about 20? 20 is kind of tough because it's not even on this. So what I could do with 20 is I could take this equation and plug my 20 into the x and do the math. 5 times 20 is 100, plus 10 gives me 110. So 20 people would be about 110 bucks. Okay? So, now what about how many people will cost $150? Well, if I use the same equation right here, I could say that this 150 is my y value, and I solve for x to figure out how many it would be for $150. Okay, I could figure out the number of people. So what I'd like for us to do, this is kind of the general steps, so let's see if we can actually do one together. So here's the data that we're going to use in order to figure out a line of best fit. Okay, so step number 1 was figure out 2 points that represent our data. So here is one point that's been chosen, and here is another point that's been chosen. Okay, and those pretty much approximate our data. So I find the location of this point, which I know is 1095. So there's my first point. Now I need to find the second point. So this point down here is 60 and 40. So there's my second point. And now, first thing I need to do is find my slope. Well, we know the slope is found by using the formula y2 minus y1 divided by x2 minus x1. And if you remember in the lesson that we did with that, I told you to identify one point is 1, the other point is 2, and then that tells me that in 1, this is my x1, y1, and this is my x2, y2. So now I start plugging in my values. So my y2 is 40, minus my y1 is 95, over my x2 is 60, minus my x1 is 10. And I do the math. 40 minus 95 gives me negative 55, over 60 minus 10 gives me negative 50. So that's going to give me, if I simplify that, negative 11 over 10. Okay, now to make this a little easier, we're going to then convert that into a decimal, and negative 11 over 10 will give me negative 1.1. Okay, so there's my slope. Now I write my equation. Y is equal to mx plus b, and now I need to plug in some values to find b. So I'm going to take my slope, I'll plug that into my m value, and I'm going to multiply that by one of my x values in my points. And I'm going to choose this point right here because both of those have 0 numbers, so I'm going to choose that one. So I'm going to take my x value of 60, plug that in, take my y value and plug it into the y spot. Now I evaluate. So 40 equals, now if you were to type this into your calculator, you're going to get negative 66 plus b. Now I need to solve for b. So I add a positive 66 to this side, I add a positive 66 to the other side, and I find out that my b is equal to 106. So now with my slope and my y-intercept, I can now write the equation that would create this line. And that is y is equal to negative 1.1x plus 106. And that's the equation that passes through those 2 points. And that's how you create the equation of the line of best fit. So until next time.